Wow. Okay. Anyway, so okay, that's not gonna work. Give me 1 second here. That's not gonna work well. Is it still good? Can you still hear? Awesome. Perfect. Okay. Okay. So Mark introduced or had the introduction here. DLL hijacking, or he said DLL sideloading. That's originally what I submitted. I have to confess that I have a bait and switch. Just by show of hands, how many folks in the audience have ever discovered a zero-day vulnerability and written an exploit for it? Mark? Okay, so I understand the reluctance in some cases. I'm sure there's probably 1 or 2 elite hackers in here who have knocked this out. I started talking to some of my peers about DLL sideloading, which is a step up from DLL hijacking. And folks kept giving me the crazy look as I was talking about DLL hijack. And I'm like, so, you know all the stuff with DLL hijacking? And they're like, no. I said, well, but DLL, and then I realized that I had to explain one before I could get to the other. Looked around, said, probably I'm going to bait and switch here. So I'm trying to gauge the audience here. Blatant disclaimer, it was advertised as DLL sideloading. It is not going to be about DLL sideloading. I'm so sorry. We're going to cover a slightly more basic but more universally applicable topic that I originally thought everybody knew about, so I wasn't going to cover it. And so we're going to go over DLL hijacking. So if you are an elite hacker and you do DLL hijacking all day long, and you want to go attend one of the blue team talks, take off. You're not going to offend me a bit. I got thick skin, right? So if you'd rather attend another track, by all means, take off. Now, I apologize for the bait and switch. If anybody really, really wants to do sideloading, we'll do that next year, right? Because then I can say, just refer back to the other talk before you come here. So who am I? A+ certification holder. I'm aspiring CEH. Hoping to pass on my 3rd attempt. I took some computer classes back in high school, so I'm a QBasic and Windows 3.1 expert. And 11 years of experience as a sandwich artist gives me a unique perspective on dealing with made-to-order security solutions, right? Okay, we all know that's BS, right? But I get tired of like those serious, you know, here's my whole CV in a slide thing. Okay, so agenda. I'm talking about motivations. We'll talk about sideloading. Talk a lot about DLL hijacking. I want to talk about auditing methods, a couple of findings, as well as some practical defenses. So why do we bother? Turns out that persistence, which Alyssa is talking a little bit about next door in the following hour, stealthy persistence techniques oftentimes will rely on injecting DLLs. Which antivirus is the best?
The one that works.
That's funny, the one that works, right? They all suck equally bad. I mean, there's a reality to this, right? No antivirus is effectively dead. Right? No antivirus is good, but I tell you that antiviruses suck especially bad, not that they're good at anything, but they suck extra hard at detecting DLLs. They just do. They tend to look for executables. We've run a number of intrusions. Brandon here has helped me out with an intrusion very recently that involved an attacker using DLLs. They were launching a DLL into a signed executable. Now, if you know anything about antivirus, you know that when you have a valid digital certificate, right, signed by a trusted certificate authority, and in this case, the malware, not even the malware, the loader process wasn't written by the attackers. They went out to CNET, they downloaded some executables, found one with a DLL hijacking vulnerability, identified that, loaded that on the machine, and set it in an auto start key. So what happens? Well, it turns out then at auto start, it's startup or user logon, take your pick, depending on how you persist. Turns out then that Windows loads the signed executable. And now if I were going to talk about a whitelisting company, I'm not because my lawyer says not to, but if I were and I were going to talk about Bit9, for instance, we would say then, possibly that then, in that hypothetical Bit9 example, Bit9 would fail to detect would fail to detect that malware loading because, of course, it was a signed, whitelisted executable with a known hash, right? Now, of course, my lawyer advised me don't talk about any particular vendors like Trend Micro that miss this also. But if I were going to talk about any of those, that would be completely hypothetical. Okay, so I'm not picking on any vendors in particular here. Again, as I pointed out, they all suck equally bad. So now attackers can make your multi-million-dollar security investment like Bit9, Trend Micro, Symantec, etc., look hypothetically, look obsolete. Right? So this DLL hijacking technique has been around for years. As it turns out, AV still sucks, and you get around executable whitelisting. Is anybody doing this? I think I already popped the surprise on this. People are indeed doing this, without any shadow of a doubt. Again, I mentioned that we're currently investigating an intrusion at a $13 billion a year company that is, these guys are printing money, for goodness sakes. Good security, some good security, sort of okay security investments, right? They have a lot of the products. They did the right thing, right? They went out and they wrote the checks for the tools. That's what you do, right? You write the checks for the tools and wait for the alerts. Again, we see this used in most of our Chinese APT compromises. Now, if you've ever heard me speak before, you know my feelings on using the APT keyword. All right, what happens every time a reporter says APT? Anybody knows this? No, God kills a kitten. That was close. An angel gets its wings was close, right? But look, the reality is, right, these advanced persistent threats, they're not going away. These Chinese folks wake up every day and they try to figure out how can we get into your network and stay there. As it turns out, then we see this technique used very, very often to bypass antivirus. As a pen tester, you want to be at least as good as the Chinese APT, and if you're not, pack up and go home. Right? The best way to emulate a nation state, of course, is to find attackers who hack like a nation state, and that's what we should all be doing as pen testers. Right? If you're doing anything less, if you show up and all you do is run Metasploit, again, go home. Right? Okay, so with that, let's get into DLL hijacking. All right, so what makes this possible? Every DLL, every executable imports a number of DLLs. The DLLs themselves import other, not surprisingly, DLLs. They have an import address table, and unfortunately the import address table, per the Microsoft specification, does not specify the path of the DLL. It specifies the name of the DLL. Now, I would love to be a fly on the wall, Microsoft headquarters in Redmond, when they made the decision and said this is the way to go. At the time, believe it or not, this is not an omission, because very often we look back and we say, wow, right, like IPv4 address space, right? Who thought 4.2 billion IP addresses was going to be enough? And then you find the truth out, right? And you find out that in reality, the original IPv4 scheme was just spelled out to be a research project that got a little bit out of control that we now know to be the internet. It turns out they even said in the paper 4.2 billion addresses would never be enough, but it'll be suitable for the small-scale research project, right? And then it took off, and we know the history there, right? Same thing here, except in this case, it's not an oversight. In this case, Microsoft looked and they said, we want to only specify the name. We want you to be able to source the DLL from a number of different paths. This will help us address a huge number of compatibility concerns. Thank you, Microsoft. Bend over here anyway. So, okay, hijacking essentially here is abusing these DLL search paths, right? We may get privilege escalation when we combine these with weak directory permissions. You want to use iCackles. If you're not familiar with iCackles, I cannot see iCackles without thinking about cankles. But anyway, use iCackles to determine if you can write to the directory of some type of system process or service. When we're doing pen testing for customers, every company bigger than a breadbox has some of their own custom applications that have been devved for their own environment. Very frequently, we find these starting up as system services. I would say 3/4 of the companies that we pen test have some type of internal alerting application, whatever it is. It's the, you know, if you're working at Jiffy Lube, it's a Jiffy Lube Express alert notification system, and you name it, right? Everybody's got one. About half the time, we find these running as a system service, which means if you could hijack that application, you get system privileges. If you don't know, system is God mode. And about 25% of those applications, we find out that they're in a directory that a regular user can write to. Now, what does this mean? Now, you can't overwrite files because you look at the actual system service itself and you can't overwrite it. But you can add new files to the directory. Well, remember what I said earlier here, import address tables don't specify the full path of the DLL. And so if it's trying to load, if my application is trying to load a DLL, and I can somehow trick it into loading one of my DLLs, it will execute my code instead of the system code. This is a good thing for me if I'm an attacker. It's a bad thing for you if you're a defender. Why is this a really bad thing for you? Well, because we've run, in my company Rendition, we've run a number of cases now where firms that will remain nameless have come in that do these big wide scope assessments where they deploy agents and they collect a bunch of data and they pull all the data back and they look at all of the auto runs and try and find badness. And they look in there and they say, go back to the company and say, hey, I don't recognize this alerter system. I don't recognize this special service, you know, for your back-end database. And they're like, oh, those are all custom apps. They're all ours. They're all good to go. And so they check the box, check the box, check the box. Big, very large security firm, who I'm not even naming hypothetically in this case because they are litigation happy. They take off, they leave, and it turns out organizations have been owned the whole time. Well, is it big cybersecurity services' fault? Heck no, right? They're looking through, they're saying, they go back to the company and say, do you recognize this? Company says, yes, we do as a matter of fact, 100% it's ours. And the reality is, of course, our attackers now have studied that application. They've even used it for privilege escalation. They were logged on with a regular user account. They managed to write a DLL. Now they're running the system. And bonus, they're persisting and they're blending in, looking like the actual users themselves. Okay, so another thing that we run into a lot, is that we have programs that may try to load a DLL that doesn't even exist on the system. This is what I like to call free beer. Right? Because ordinarily, if I've got something that's trying to load a bunch of DLLs and the DLLs really exist there, I have to try and, I'm kind of in a race. I want to try and get in a higher position in the search path so it finds my DLL first. This one's free beer because it's never going to find the DLL. And so if I can simply say, here's a DLL, would you like to load it? It'll say, why, yes, I would, and run my code. And of course, I like this, right? In many cases, legacy code, maybe sometimes checking for an available plugin. Sometimes I don't understand why it's doing it. Very often, well, I'll tell you, I've given up trying to figure out what programmers, particularly the in-house programmers at organizations, are actually trying to do. I don't care, but if they try to load a DLL that doesn't exist on the system, again, we can win automatically. Code takes another path if the DLL fails to load. Rob Lee kind of coined this term, ghost DLL injection. I haven't heard it termed anything else. I haven't heard anyone else use that term either, but I figure that's as good as anything else, right? So it's essentially then a place where the application tries to load a DLL that does not otherwise exist on the system. We simply put a DLL with that particular name in one of the search directories, and automatically we win. Of course, if you supply that, the app blindly loads it for you. So what are the rules of Fight Club? Don't talk, no, wait. So safe DLL search mode. This is on by default. Used to be that safe DLL search was not the default. Around 2000, 2001, Microsoft fixed this for us. You gotta be thinking at this point, come on, man, it's 2015. Why are you talking about something that Microsoft fixed in 2000 or 2001? That's because about 40% of the organizations that we've been to in the last year, I say we being my very unscientific sample set of my consulting company, about 40% of the organizations that we've been to in the last year have turned this off. Why? Because compatibility. Because we go turn it on and a bunch of their stuff breaks. Because some of their custom coded apps depend on safe DLL search being turned off. And when you turn it off, it's a global thing. It's on the system, whole system. You're not turning it off for one thing, you're turning it off for the whole system. So safe DLL search on by default, it moves the current directory. We're going to talk about the search order here, the current directory to the end of the search order. Loading the DLLs from your working directory, let's be fair, is freaking dangerous, right? Picture a case where, let's say hypothetically, WordPad.exe has a vulnerability where when you open up a docx file, it'll try to load mappy32.dll out of your current working directory. And I said it hypothetically because I would never drop something like that here without notifying Microsoft first. So, but let's say I tried to do that. If I then sent you a docx file, and WordPad were your go-to for opening up a docx file, and a copy of mappy32, let's say in a zip file, extracted the zip, your working directory could very well be then, is going to be the same place that we drop our malicious mappy32.dll. Okay, so loading DLLs from the working directory, always dangerous. Microsoft said, okay, we've got this whole search order thing going on. Tell you what we're going to do. We're going to also create known DLLs. These known DLLs, these are system DLLs like kernel 32, user 32, very common DLLs that Microsoft said, I don't care about compatibility. This is always so dangerous for someone to replace kernel 32. You're always going to go look for it in the system directory. Don't even examine the search path. So for everything in known DLLs, game on, we can't play with those, right? As an attacker, we can't play with those. As a defender, if you look at some of the DLLs that are not in known DLLs, you may want to add extras there. That's a common defense that we see or that we work with organizations. of course, again, test your code because you may well be breaking something else. All right? Okay, so what's the unsafe search path? The unsafe, the old default, as it were, and like I said, about 40% of organizations in the real world that we're seeing still follow this. It's the current working directory. Again, this is bad because you have to assume that we can insert a DLL, the attacker can insert a DLL in the current working directory. And then we look at the directory from which the application is loaded. Number 2 here is another one that bothers me greatly because, again, if we're looking at the directory from where the application itself is loaded, this could be, for instance, if we have weak file system permissions. Notice here, this is the unsafe, but as we pop over to the safe search, all right, and I want to highlight this here, even as we pop over to the safe search, number 1 is the directory from which the application is loaded. Picture now that I've got a custom application in C, program files, my special app. All right? And my special app.exe is vulnerable to this DLL hijacking, meaning that it loads a DLL. When I say vulnerable to DLL hijacking, what I really mean there is loads a DLL not explicitly listed in known DLLs. It's a pretty small list. On Windows 8, that's about 20 DLLs. If you look in Windows System 32, you'll know there are far more than 20 DLLs. Right? Your odds here are not good. As a defender, your odds as an attacker are phenomenal. All right, so again, if you have weak file system permissions, we can find those with iCackles. We may be able to write a DLL again into that, and this is with safe search. Right? Remember, this is the safe one. The unsafe one actually includes the current directory. The other one I want you to look at here is number 6. Number 6 doesn't change either, and that's everything that's listed in the path variable. All right, so everything listed in the path variable. This is another thing. As a pen tester, when you first get on a machine, right, maybe you're trying to elevate permissions, you're not a regular user trying to elevate the system on that machine, one of the first things to check is path. And see, can you write additional files into the path directory? Now look, that's always bad anyway. Right, if you can write additional files in one of the path directories there, always bad. You may be able to find other ways to elevate. But odds are pretty good if you can write into one of those directories, and things like Ruby has had vulnerabilities with this in the past, where you did the install for all users. You could then write into the Ruby directory, which was also set in the system path for Windows. Mind-blowing, right? They fixed that recently, but still definitely we see a lot of problems with this. So again, anything listed in the path variables can also get hit. So what's the common thread or threat? Look, path, again, check for the DLL. It's not found in another directory. It's at the bottom of the list, but remember, we care significantly about DLLs that aren't found, right? So we want to use tools that we can try to identify places where one of our executables is trying to load a DLL and gets a failure. If we see that, that is almost always a place where we can capitalize by placing our own DLLs in one of these special directories. What are the special directories? Again, both safe and unsafe. And again, if you get it in the path, you're set. If you can get it, for that matter, in the directory from which the application is loaded. Again, same deal, big winner. Current directory, I know I show safe search and unsafe, and it just matters where this current directory gets moved. There's a registry key. I've never seen it used in a live environment. There's a registry key where you can completely strike the current directory out of the search path. I don't see it used. Right? I see it turned off in most, I should have said never. I say never. Doesn't matter. Most of the time it's off. Bottom line, where do you really want to hit? You want to go after the path variable, or again, the directory from where the application is loaded. Great. So we've talked a lot about this. We kind of should have at this point kind of a feel for what are we looking for. The next question is, how do we find it? I forgot about the known DLLs, right? So known DLLs, again, don't use this typical search path. They're always found in the system directory. You want to look at what are your known DLLs, and again, as a possible defense, you can add additional known DLLs. Here, this then removes the ability for attackers to use these. Known DLLs are not static across all versions of Windows, right? So Windows 8, the list is different than Windows 7, different than Windows XP, different than Windows 10. So again, I want to make sure that you know what's set on your particular environment. I have seen multiple cases, again, in organizations where folks have removed system default known DLLs. I almost never see anybody add them, but we've seen cases where folks have removed pretty important things like user 32 to solve a compatibility problem. This is not the way to solve the compatibility problem, right? But again, we all know we're security professionals, right? Security is the enemy of usability. Well, sort of, right? I mean, it's not supposed to be that way, but it is. Okay, so Windows allows users to exclude DLLs from known DLLs processing. Again, definitely some strangeness there. Allows override of the default behavior. You don't want to rely on these defaults when you move into customer environments because these coded applications, some of these poorly coded applications, usually remove. I haven't seen any add, but again, who knows, right? Custom apps for some customer environment. Well, how do we want to test for this ghost DLL injection? Because I talked about the fact this is the most dangerous piece. Because when you have a DLL, the application tries to load the DLL. The DLL exists nowhere on the machine. That means anywhere that you can place it that was in that search path, you win. How do we test for it? One thing that we can do, and Brandon helped me write some code for this. Brandon, raise your hand there, because he's an outstandingly smart guy. Help me write some code for this where we're looking at the import address table for our executables, and then we're actually running strings against the executables looking for references to other DLLs, assuming, of course, it's not going to be obfuscated, right? I know malware obfuscates stuff, and this isn't a 100% test case, but it's a good start for us to start looking there. We can run a code with a debug, or run the code with a debugger attached and set a breakpoint on load library. We'll talk about G flags. How many folks have used G flags before with a debugger? Anyone? Okay. Mark? Really? See, I expected like Mark again to raise his hand wildly. G flags is an awesome tool. If you've never used this before, this is like a huge takeaway because even if you don't know what you're looking at, you look really smart doing it. And then you can reverse engineer the application without a pro. That's where we really take it another step up. So registry keys, these are just here for reference. What are we going to do auditing-wise? Just talking about G flags with WinBag. H.T. Moore wrote a DLL Hijack audit kit a few years ago. This one still works pretty well today. Dependency Walker. Security Exploded has a nice GUI tool, and if you can't do anything else that I'm describing here, you look at it, you're like, that's all too hard. Download Security Exploded's DLL Hijack Auditor. Caveat, I have not reviewed this for its own security. Like, for all I know, they could be backdooring your system or something with this. It's a free tool. You know, when something's free, you're the product, right? So I have no idea what else the tool does. All I know is that it was a nice GUI tool, and it uses to audit, and it either says good or bad, right? And I like that. That's pretty nice. And then, of course, Procmon. We'll talk about another tool called SSXTrace, although this is much more useful for DLL side loading than hijacking. So G-Flags. G-Flags is a tool for free included with the Windows debugging tools. Great for finding memory errors. We use this all the time in exploit development for finding use after free conditions or double fetch conditions. G-Flags, again, excellent tool, but in our case, we're very interested in the SLS flag, the show loader snaps. Because as it turns out, the loader is, well, as the name implies, what loads DLLs. And we want to see the snapshots of exactly what the loader is doing. If you've ever been curious about what the loader is doing and how it's trying to resolve DLL names and all the DLLs it tried to find to load and didn't, Show Loader Snaps has all that information. I'll tell you all that and more. So again, it shows us which directory they're loaded from, any side-by-side redirection. Side-by-side is a compatibility piece for Windows that allows you to have multiple versions of the same DLL on a given system. And side-by-side will help you figure out which one of those to load. This is often used by malware as well. It also shows functions explicitly imported. So again, lots and lots of data for free. So how do you find craziness of G-flags? One, don't do this on a production system. All right, so we want to start with some dev system that's representative, of course. Maybe just take one of those clones of your golden image. All right. So we're going to do G-flags minus I. I'm going to say the tested executable, whatever it is we're testing. Let's say I'm testing WordPad.exe. And then you do a plus SLS. That's going to set a global flag where every time you launch WordPad, it's going to generate tons of debugging information in the background, whether you're looking at it or not, right? So this is why we don't do this on a production system, because it's generating all this output, generally on a production system. Whether you're looking at it or not, it's going to slow your system down. You really don't want to do that. But it does, it outputs a ton of data, probably more than you're interested in. What I generally highlight here when I'm looking for DLL hijacking is find or map dependency. All right, so if you output all the data to a text file and go look for find or map dependency, kind of get an idea here of some of the data here. We see the find or map dependency. Here we're looking for the VCRT, the Microsoft Visual C Runtime DLL. We can see that we located it here in Windows System 32. So this one's not a candidate. All right. Well, it might be. Depends on if it's in known DLLs, because remember, even with my unsafe and my safe, notice that if I've got an MSVCRT from which the application, the directory from which the application is loaded, if WordPad, let's say, is in program files, Windows NT accessories, hypothetically speaking, of course. Well, that's not hypothetical, ridiculous, right? It's in that directory, right? But if we were auditing that, for instance, right? If we could write a DLL there, now Microsoft doesn't script directory permissions like that, but others might. We could get it there no matter what, even if it isn't system32, because that directory comes first. What's the rub here? The rub is msvcrt.dll is a known DLL in every operating system I've ever checked. So again, known DLLs don't follow the search path. But again, we're going to take the rules as we understand them. We're going to run G flags. We're going to open up our application, drive it around for a couple of minutes, and then sitting back in our Windows debugger window, we're going to have more data than you can shake a stick at. And then you're going to search through and look and say, okay, what DLLs did it try to load? By the way, if it tries to load a DLL and fails because it can't find it, for instance, that gets logged here too. And pretty quickly then you can look and say, now in this case, MSVCRT, this is an easy one. It was present, but if it doesn't find the DLL, again, it gets logged here too. We can work against that. HDMore did a little bit easier. I call it kind of an easy button. DIY for file extensions. Now, he's helping you do DLL hijack auditing. The concept here, and this stops short of a full system audit by a long shot, but the con-op, the idea here with HDMore's code, is that you're trying to exploit somebody, let's say by sending them a zip file. Now coming back to the WordPad with the docx extension, I would send them a zip file. The zip file would include a docx and a malicious DLL. And hopefully the user would unzip, and of course that would go into some, whatever is working directory, and then he would double click on the file and also load my malicious DLL. And because HDMore, as you probably know, wrote Metasploit, that's the thought that he's doing as well. And so he only tests applications on the system that have registered file extension handlers. So the way that the tool works is it's going to go check the HKey class's root. It's going to go look for all the registered file extension handlers, walk through each one, generate candidate tests for each file extension handler, and see is it vulnerable to DLL sideboarding. Again, or sorry, DLL hijacking, excuse me. DLL hijacking. So again, not a perfect tool, but it is a pretty easy button kind of approach to getting this work done. It does require Procmon, so you're going to have to download Procmon from someplace. But Mark Rusinovich is nice enough to provide that for free. So we use this to successfully find some vulnerable programs on a Windows 8.1 instance that I use all the time. The pros, I'm probably the only one that uses a Win 8.1 instance, and honestly, it's only because of SAMs. Because Microsoft's crazy with all their licensing stuff, and we have to use Windows 8.1, moving up to Windows 10 now. But the pros, very, very easy to use. The cons, unfortunately, it only tests default handlers. And even then, it can be impacted by some DLL loading delays. You can configure how long it's going to run the application for. But in some cases, you actually have to drive the application to make it load a DLL. A great example of this is PowerPoint. If you try to do an org chart, has anybody ever tried to do an org chart in PowerPoint? One, this is ridiculously painful. Don't do it. Use Visio. But if you do use PowerPoint for whatever reason, PowerPoint loads a separate DLL because you're using an org chart. It recognizes the org chart has a DLL that has functionality that you load in because the file contains an org chart. The second you click in the org chart to edit it, it loads yet another DLL. Now let's say, for instance, and this isn't even a hypothetical, it's not vulnerable in this case to the side loading attack, but let's say, for instance, that it was, right, or excuse me, the hijacking attack, let's say that it was, HDMore's file extensions would miss this. One, because it's only going to generate a fake PowerPoint file and hope that it, basically launch PowerPoint, right? It's going to generate a file with that extension, launch it, hope that, basically look for whatever DLLs are going to get loaded. Because we're not driving the application here, because the script is automatically firing stuff off, we're not actually going to see any results here, even though the application's vulnerable. You guys follow me here? Essentially, because we're not driving the app, we're not doing all the things the app would ordinarily do under user behavior, right? With user behavior, again, we're not going to see it. I like the fact that it's really, really easy to use. My mom could use this tool. She probably couldn't interpret the results, but she could use it, and that's enough, right? So that works well. This is on my Windows 8.1. I blocked off. This is an image that we've been working with, or that I've been working with for a while. You can see the one that concerns me a lot is this MSI extension. He found the MSI extension to also be vulnerable. I found that to be quite concerning, to say the least. Right? Turns out that it's not Windows screwing this up. It's actually a third-party tool called HackShield that, ironically, then screws up the MSI file. Anyway, neither here nor there, right? How cool is that our security products actually are then screwing up? Yeah. So again, I blanked that out to preserve the, I guess that's not the innocent in this case, but you get the idea. So this is Procmon. If you're not familiar with Procmon, we'll take a look at, or talk a little bit more about this as we go through. It's a great, great, great tool. Procmon ordinarily will generate, with you doing nothing on Windows, tens of thousands of events per minute, right? If not hundreds of thousands of events per minute. You need the right filters in place. HD Moore's tool puts all of the right filters in place for you. That makes it exceptionally easy to use. One thing that I want to point out here is the DLL referenced isn't always loaded. All right, so WordPad.exe looks really, really bad when we started doing the audits here, and we saw indeed. As a matter of fact, I'll go ahead, and this one's an easy one here. This is WordPad up here at the top, although I've got it blanked out, and you can see it's trying to load mappy32.dll. If you know anything about mappy32.dll, it's a legitimate Windows system DLL. It should be in system 32. Unfortunately here, of course, my system is trying to load it from my working directory. No one likes that, right? So I did a little bit more study on this particular one, and it turns out that in this particular case, even though it's trying to reference the DLL, it doesn't actually load it. It doesn't actually load it from there. There are a couple of checks inside WordPad because Microsoft looked and said, this would look really bad if some guy came in and found one this easy. And so they put a couple of checks in there that prevent it from loading in that scenario, right? Your in-house developers did no such thing. All right? I promise you, your in-house developers did no such thing. It requires a little bit more investigation with a debugger to see if it's exploitable in any circumstances. Hint, it is. Anyway, so Dependency Walker, right? Let's talk about other tools here. Dependency Walker is another easy-to-use tool. Very, very easy to use tool. One of the things I want to highlight here, a lot of times folks look at Dependency Walker and they say, good to go. This is a quick analysis tool, and I've got this thing that looks a little weird over here. I think it probably isn't malware, but I'll just drop it in Dependency Walker and see what happens. It's not a good idea because Dependency Walker, it turns out, uses the Windows Loader to load DLLs. You can see where this could go horribly wrong if your program depends on one of a set of malicious DLLs on the system. All right, so again, this is another good tool for offline, right? Offline use with one of your golden images. But again, we'll show you the location from which DLLs get loaded into the app. The most interesting thing I always find are the ones that aren't found. What can we do with this? Again, privilege escalation. These admin tools usually run with elevated permissions. Of course, we want to check service auto runs. If we look in our services key, if we can find any services, if they're running out of Windows System 32, no-goes, right? You can't win there. If you have to write something in Windows System 32, you already got to be system in the first place. You're not elevating. You want to find those services that are running in those weird directories, right? Preferably ones that you've never seen before going in and working with customer X, all right? So again, the pros very, very easily finds missing DLLs. Unfortunately, one of the cons is it doesn't address all runtime DLL loading scenarios. HD Moore's tool suffers from this as well. So Argon. Argon is if you're not familiar with Argon, Argon is an admin tool that allows you to set multiple network profiles on a given machine. Like sometimes I want to have a particular static IP address, and then sometimes I want to be DHCP, and then another time I got to set it up this way, and I get tired of typing that stuff in, and I fat finger a lot of stuff. Argon will store those for you and set it. If it stores those and sets those, you can imagine that it runs with elevated permissions. And it would be really, really bad, of course, for it to have a vulnerability like this. Argon.exe, as you can see, can't find a number of DLLs. Right? So Dependency Walker looks at Argon.exe, can't find a number of DLLs here. This one in particular, ieshims.dll, you should write this down. If you take nothing else away from this, as an attacker, this is a big one, and as a defender, this is a huge one that my Mandarin-speaking friends really, really, really like to use. And you should know all about ieshims.dll. And if you only do one thing when you go into work on Monday, how many folks are actually defenders here? Yeah, that's usually the case, right? In a red team talk, like half the folks in here are blue team. I want to find out what the bad guys are doing so I know how to defend. And that's smart. It really is. Go in, do a recursive directory walk on a system, look for ieshims.dll, and look for places where it shouldn't be. All right, so it should be in program files, common files, something I can't remember right off the top of my head. But if you find one of these in, I don't know, C, users, public, app data, whatever, probably not a good day. There's probably something bad going on here, right? Again, my friends in the Far East, they love this thing. And the reason is because you're going to you're going to walk away from this, and if you download Dependency Walker, another free tool, and you use Dependency Walker, you're going to find that a huge number of applications are missing IE shims and can't resolve IE shims. And you're going to find huge numbers of these that can't resolve IE shims. And again, our Chinese friends know this too, right? The reality is that at runtime, the program may or may not correctly load IE shims. Again, like I said with the Dependency Walker, does not correctly work in all runtime scenarios. It can't mimic all runtime scenarios, but again, a good tool to use. So the DLL Hijack auditor, security exploded, again, great way. This is the easy button, the Staples easy button. Actually, knock that Staples. It's not Staples. That's I'll get sued there. But the easy button, regardless, DLL Hijack auditor, very, very easy to use. You just download the DLL Hijack auditor, plug your application in, let it go. We can see here the vuln test is finished, and no vulnerable DLLs were found for WordPad.exe. Now, is that really true? Maybe, right? You can see here where we're getting a heck of a lot less data than we were getting from HD Moore's tool, because we come back here a little bit, and like I said, I blacked this out for litigation purposes, we'll say, but regardless here, the top two lines being WordPad, you can see that there was an attempt to load mappy32.dll. I like the extra output here a heck of a lot more than I like, because I've still got some hope here. I know I need to dig deeper. Because there are 150 some odd file extensions on this particular Win81 machine, and only a few of them flagged. That's not a snippet, that's the whole screenshot. Alright? So only a few of them flagged. I'm going to dig a little bit deeper here. But when I run the DLL Hijack auditor, you can see here, I get no indication that I should dig deeper here. And so while I like this as an easy tool, and I certainly have had it pop and say, hey, there's definitely a vulnerability here, there have been other times when I know there's a vulnerability there and this thing fails to detect it. Right? So it's not the top tool in my chest, but it is by far the easiest to use. Right? My mom, again, can use this tool with no problem, and she's a technotard. Okay, so we can go native with Procmon. Right? I'm not even going to try and pronounce that guy's name. Actually, that could be a girl for all I know. I don't know. He has a great article on auditing for ghost DLLs using Procmon. It's really interesting. I didn't even know about this prior to starting this talk, but I was looking for references. It's the kind of stuff I've been doing for years, and it turns out this guy published an article last year on using Procmon to do exactly the same thing, looking for those missing DLLs. Basically, we want to look for the operation of create file with a result of name not found. If you're not familiar with the Windows API, Microsoft kind of plays a little trick here. Create file really means create or open. So create if it doesn't exist, open if it does. And we want to look for name not found. Why? Because, well, when we talk about the search path, how are they doing that? They're going into each directory, and they're calling create file. All right, and so we want to look for those places where it says name not found, and then we'll filter down and look for file names with the names of DLL. Load image operation, again, is also useful to filter for these missing DLLs. One final tool I want to talk about here, SSXTrace. If you don't want all the detailed information for debugger, and I understand because debuggers are hard to use, and again, they will make you look geeky and awesome, though. If you don't want all the detailed information, SSXTrace will help you get some level of data back here. SSX loads. Basically, what's going to happen here is we'll find out which version of a particular DLL is being loaded by the application. I mentioned earlier, Windows side-by-side SXS allows you to have multiple versions of the same DLL on a given system. All right, and so if you want to know which version is being loaded by side-by-side, this tool will help you out there. SSXTrace in action. This one pretty interesting here. Very specifically here, why am I interested? Because we started an assembly, essentially here, meaning, well, it's looking for a DLL. At the end of the day here, it didn't find the DLL it was looking for. Winner, winner, chicken dinner, right? Because again, if we can put that someplace where it's going to be found, again, this is a great trace tool already available, built in for you by Microsoft. So practical defenses. Number one, there's no good defense against this. Let me go ahead and just say there's no good defense against this. This is built for, the whole idea here was compatibility. You have to audit the software on your machine. Your in-house developers, and I put that in quotes for a reason, all right? Your in-house developers are not security experts. In fact, in universities, no offense to GRU in particular, but in universities, we routinely teach students how to code incorrectly, how to code poorly and incorrectly. It makes it work, but it's wrong. I still attend, I was actually at a university last year where I was doing a guest lecture, and up on the board, I kid you not, up on their big whiteboard, up on the big whiteboard, they had stir copy. And I looked and I said, holy goodness, it's 2014, are you still teaching students stir copy? For those who don't know, by the way, that's a vulnerable function, always has been, always will be, right? No, we're still teaching them stir copy. Mind blowing, right? So again, stir copy, by the way, prior to Heartbleed coming out, was all over the OpenSSL code base. Go SSL. So we don't want to rely on the automated tools. They don't catch everything. I showed a couple of good examples, or at least one good example of that, where automated tools were definitely not catching everything. And even HD Moore's tool, as good as it is, doesn't catch everything. Of course, from a defense standpoint, if your devs don't know what to do with this stuff, again, hire some testers who actually do, who know how to do more than Nmap and Nessus. Oh, and scope the pen test appropriately, because as any good red teamer will tell you, I asked who earlier was blue team, and I presume the rest of you are red team are afraid to raise your hands. You know then that most tests are scoped incorrectly. There's no way that you're going to have time to audit this level of detail across the system. Always check permissions. Always check permissions. Earlier I said there's one thing you should do, right? This is the second thing you should do, right? First thing was go look for IHMs, because our Chinese friends use it. Second thing, go back, look at your path variable. Open up a command prompt, type the word set. It'll show you your path variable. For each directory in your path, go check permissions. Run iCackles against that directory, right? Or cankles if you prefer to think of it that way. But go run iCackles and see, can an authenticated user write to the everyone group, the authenticated users group, right? Can they write to that directory? Because if they can, you're all kinds of pwned. .NET developers, of course, need to be specific in their manifest. Windows developers, Windows developers are just as bad. We want them to call load library with an explicit path. Don't rely on the system to walk through the search path. I think we've identified that that's probably a losing bet. Right? In particular here, we're really worried about about processes that begin as services, because they generally then start as a system user. If your developers really don't know what directory the DLL is going to be in, so they can't call load library from a specific path, there are other APIs, set DLL directory and add DLL directory, that can be used in their place. All right, so that'll allow you to add additional DLL directories to the search path. When I'm auditing code and I see those two calls being used, I generally just stop and move on to something else, because I know the developer knows something about security. Plus, I also see stir copy in the same application, in which case, they have multiple personality disorder, or there are several people on the team, I don't know, something like that, right? Okay, so before I go, my company's hiring. If you are looking for an awesome security gig, come talk to me, really. All right, so I'm looking for SOC, pen test, and forensics folks. I have sysadmin slots and developer slot available for the right candidates. I'm not just looking for Johnny sysadmin, but I assume if you're here, you're probably the right candidate. Anyway, all the way from entry level to subject matter expert, come talk to me. And with that, I'll turn it over for questions. Fire.
Can you give us the 3-minute preview trailer to next year's talk on the topic?
The 3-minute preview or trailer? Yeah, no, actually, because I've got the 5-minute, but I'll give you the 1 minute. And it's all about side-by-side manifests, SXS manifests. Right? So if you want to get some information on this, the best resource, believe it or not, for this is Microsoft. WinSXS, go Google WinSXS, try saying that 5 times fast, and MSDN. Go out there, and they have a good set of documentation on how to work through for your developers, how to specify your DLLs in the manifest. Essentially, the problem here is that developers will say something like, "I would like the Windows Common Control DLL version 6 or higher." Right? And so there's, let's say, Common Controls DLL version 10. Right? Well, it turns out then, in that particular case, the first one, 6 or higher, is used. And so I could then go back as an attacker and I could insert version 9. And whereas you thought you were loading the old, now this is not a privilege escalation. In 99% of cases, DLL side loading is not used for privilege escalation. But it is used for some really awesome stealthy persistence, because our antiviruses, they are just really bad. Really bad at detecting that. And it's much more difficult for us to detect as blue team members as well. So that's a quick preview. Any other questions?
Have you seen any
Have I seen rootkits in Windows 8 or Windows 10? Mildly off topic, but the answer is yes for Windows 8, no for Windows 10. Two things with that very, very quickly. I know I'm running real short on time, but part of the problem when it comes to rootkits, I'm going to assume what you really mean there is kernel mode rootkits that do things like kernel object manipulation. You have a couple of intricacies here. One is Windows Patch Guard, which is a giant pain in the rear. When Windows Patch Guard detects that you've changed something that it's actually guarding, it causes a blue screen of death. That's bad for you as the rootkit developer. The second one is driver signing. It's very, very difficult, as we all know, to get a driver signing certificate. It's not difficult. It costs $200. They want to verify they have a website and a phone number, which is a very, very high bar. In some cases, for an extended validation certificate, like we see in Windows 10, you need an address as well. Nobody will visit the address. So you will need an address, though, that actually corresponds with the phone number and website that you put together. It is not difficult to get a code signer certificate. So, but if you don't want to go to that trouble, you simply look for a device driver like Fortinet that was released 2 weeks ago that has an arbitrary write what where condition. In that case, you simply use that write what where to flip the 1 require signed drivers to 0. Don't require signed drivers in the kernel, and then you load drivers at will. Right? It turns out that that one is a signed driver. Right? So even if you didn't have Fortinet on your system, you just take it with you. Right? VirtualBox has had a number of these. There are a whole set of vulnerable device drivers. You take one with you, you install it as a service, you load it, and then you exploit the driver that you brought with you to turn off kernel mode code signing for the win. Okay, I think I'm out of time for questions. Mark, I appreciate the time, by the way, all your time. I know how valuable it is.
So if we're taking